What I'm going to do is I'm going to put a triangle right here, and that nice pretty triangle. Right. Now watch what I do. Since I got the computer, this is kind of nice. Watch, I can copy and paste. Do you know what the universal key things are? Control C, right? Control C, and what is the paste? You'd think it would be P, but it's not. It's V, isn't it? And it's V because it's right next to the C. Yeah, P is print, and V is right next to the C, so it's Control V. This is no, that's not it. Thank you. I'm on a completely different chapter. That was from my other class. So what is it? 4 what? 3? Okay, 4-3. Thank you, Leah. All right, now I got to go back to this and change this. All right, sorry. This shouldn't take too long. All right, here we go. So what do I have now? I have two triangles that are identical. Okay, exactly right. This is one thing I was never able to do on the board or with a regular overhead, but this is kind of cool. Watch, I can take this triangle right here, and I always say this. For years and years I taught geometry. I always said, what if you took this triangle and put it right on top of the other one? And I could never do it, right? But now I can actually pick it up. All right, actually, let's pick it up and hold it. Yeah, there we go, and move it around. Just since the last marking period last year, so this is only my. Anyway, so look, I could put it, and it's right on top of it, isn't it? Would you agree? Okay, yeah, it makes it look a little darker, but then I can scooch it out here. So would you agree that they're identical triangles? Now, we don't call them identical triangles. In geometry, when things are equal to each other, I let you say equal, but what's another word that we use? Congruent. So we say that these are what? Congruent triangles. Now, I really do want you to use the word congruent when we're talking about triangles. If you talked about the lengths of the sides or the angles, I'm okay personally if you say the sides are equal or if you say the angles are equal to each other. Okay, we kind of use them interchangeably. Is everybody paying attention? Okay. Could call your name out for the whole world to hear, but I just looked. All right, so here we go. So these are congruent triangles. Let me show you a couple reasons why they're congruent. Let's name this one ABC for lack of imagination, and we'll call this DEF. Right, what's your middle name? Blake, the one that was talking earlier that I had to stop for. Austin, Blake, Costello. Everybody's watching this. What are you kidding me?
Everybody's watching.
The world's watching. Okay, here we go.
No, you took his middle name.
All right, shh. Benjamin, listen. You gonna stop? All right, here we go. So I've got these two triangles, and they're congruent to each other. So if they're congruent to each other, they match up perfectly. Tell me something about line AB. If I put one little tick mark here, tell me something over here. It's congruent to what? It's congruent to. It's not parallel. There's no parallel. They're congruent to. The lengths are congruent to each other. Okay, they're equal to each other, so the lengths are equal. So if I put one arc here, if I put two arcs here, what's AC equal to over here? DF. Okay, what's BC equal to? EF. You follow me? Or we could do the same thing with the angles, couldn't we? Let's call that with one arc. So what's over here? What's equal to angle A over here? Angle D. All right. What's equal to angle B?
E.
E. And then what's angle to equal C?
F.
F. All right. Pretty easy to understand, isn't it? So if I can take one, pick it up, put it right on top of the other, do you see how A and D went together? We call those corresponding angles. Now, it's not the same kind of corresponding, not exactly the same kind of corresponding angles that we talked about when we did parallel lines, is it? But really the word kind of means the same. When they're corresponding to each other, it means they match up, right? They're basically in the same spot. So, look, A and D are basically in the same place, aren't they? All right, if I took this triangle and put it right on top, the A and the D would match up with each other. Does that make sense? So we call them corresponding angles. What about AC and DF? I would call those corresponding what? They're not really lines, but what are they of the triangle?
Angle, sides.
Which one? You can't say both. I mean, they're two angles and sides are two completely different things. AC and DF are sides, so we say corresponding sides. So watch. If the corresponding angles are equal to each other and the corresponding sides are equal to each other, then what can we say about the two triangles? They are what? That's right. They're congruent. So if the corresponding angles are equal and the corresponding sides are equal, then the triangles are congruent to each other. Does that make sense? Yeah. All right, so there you go. Now, we're a little bit picky on how we name these things. You can name this triangle, and you can use all sorts of different ways to name this triangle. Somebody give me their favorite way to name this triangle. Triangle ABC. That's a good way to name it. All right, so triangle ABC. I'm going to write congruent. I always write congruent when I do triangles, okay? I don't ever say triangles are equal to each other. I say triangles are congruent to each other, all right? So triangles are congruent to each other. If I call this ABC, the letters on this other triangle, you can't just use any combination of D, E, and F. You have to make sure that the vertices are the corresponding vertices, okay? They're in the same order. So if I go A, B, C, what am I going to have to go over here? D, E, F. You have to, right? It's not a suggestion. It needs to be D, E, F. Because look, when I look, if I didn't have a picture of those triangles and all I had was this, I should be able to tell which angles were equal to each other and which sides were equal to each other. So pretend I didn't even have this picture of these two triangles. Just looking at this, what angle is equal to angle A? Angle D. Does it make sense? Just by looking at this congruency right here, I can see that A and D are equal to each other. Keep talking. What? Angle B and angle what? E and angle C and angle F. They're equal to each other. Would you agree? Without even looking at that picture, just by this information right here, I know that that stuff's equal to each other. That's why it's important to make sure that the corresponding parts match up. You get it? Now, when I say that phrase corresponding parts, we're not going to deal with this very much today, but in the future, this is going to be really a big deal. If I talk about the corresponding parts, what parts are there to a triangle? Well, there's angles and there's what? And there's sides. So when I refer to the corresponding parts, I'm talking about all the angles and all the sides. Does it make sense? And you may look at that and you think, well, big deal, who cares, the corresponding parts? But it's going to be a big deal a little bit later on, okay? I'm just throwing it out there. Everybody good so far? All right. What else could we say? We said the angles are equal without even looking at the triangles. Okay, cover it up. In fact, watch. See if I can... I don't know. Can I do this? Oh, there we go. Oh, I don't know. Forget it. I was trying to... Oh, I know. I can do this. Watch this. I'm going to cover it up. Boom. And then fill. And then boom. There it is. See? Covered it up. Isn't that crazy? All right. So now, without looking at the triangles, just looking at this thing right here. I know the angles that are equal to each other. Let's go to the sides. So let's take a look at this triangle. I can tell what all three sides of this triangle are, can I? So what? Side AB is congruent to DE. That's right, because that's the first and the second one. Do you see that? All right, DE. Oops, I know why it's doing that. Because of this thing right there. I gotta go back to that. Okay, so AB and DE are congruent. Then what else? Give me another side. BC. All right, so BC is congruent to what? EF. Good. And then what else? AC. Right. AC is congruent to DF. I mean, it's not difficult, right? It's not that hard to figure out. But it's important stuff because we're going to use this a whole bunch later on. All right. So I want to make sure we have a good, solid foundation on this stuff. Everybody good? All right. All right. Enough of that. Get rid of that thing. So there we go. So you can see that, watch, AB and what? DE, they're the same sides, aren't they? You see it now? And then BC, this bottom one, and EF is the bottom one, and then AC is this one on the right, and DF is the one on the right. All right, very good. Let's move on to something else. Okay, here we go. Got two congruent triangles again. I copied and pasted, so you kind of know they're congruent. Watch what I'm going to do, though. Actually, you know, before I actually copy and paste, I'm going to do this. I didn't want that. I want that. Okay. Watch. Let's just do this. We might put one arc here. We'll put two right here. Is that all right? And I'm going to group that all together so I can move it around. So now what I'm going to do is watch. I'm going to copy and paste it so it's exactly the same triangle. So what are they to each other then? They are congruent to each other. Let's just take this one and play around with it a little bit. Let's kind of swing it around. I don't know, about like that. Is that all right?
Yeah.
And let's do this just for fun. Let's reflect it about that. So we kind of flipped it. You see it? So I twisted and I flipped. I don't know, and let's, I don't know, go like that. Make it look really different. Is that all right? Well, then I would just keep going. It's a rhetorical question.
It's a dictatorship.
All right, that's right, it is. All right, so let's take a look at these, and let's name this. Let's do something else. Benjamin, what's your middle name? Come on, give it to me.
I don't have it.
You don't have a middle name? You don't? Let's make up one.
No, he really doesn't.
Benjamin Franklin Holly. Okay, so there we go. All right, stop. Actually, it's funny you said that because in the first class, the one kid gave his middle name, and it actually was Franklin, as no lie. Okay, so there you go. So that could, it was this stuff that we were doing. Yep. All right, isn't that amazing? I can't even remember now. I'll tell you the truth. It was. I don't think it was that guy. I can't remember. Anyway, let's just take a look. All right, so let's do this. So if I call this BFH, who else? Let me give some another. Chris, what's yours? We can't have two C's. You can't have two C's. What's your middle name? Okay. Goodness. And then oh, we got an H there. Make up another last name. Okay. Wilson. All right, there we go. All right, so there we go. What I want to do, though, here's these two triangles, and let's say these two triangles are congruent to each other. In fact, well, actually, we don't know they're congruent right now. But here's something. Watch this. If this angle and this angle are equal to each other, then how would you find angle H? Let's say you knew the numbers. You knew the degree numbers. Allie, what do you think? Exactly right. You would take these two, you'd add them up, and subtract them from 180 to get that one. Now look over here. What about angle R? You're taking the same two exact numbers, aren't you? Adding them up, subtracting it from 180 again. So you tell me something about angle H and angle R. They got to be equal to each other, right? They're congruent to each other. Do you agree with that? That's actually a theorem. And they call it, let me flip the page here, they call it the third angles theorem. Third angle, right? Because that's your third angle. Basically what it says is this. You watching? If two angles of one triangle are equal to each other, I'm sorry, let's say it again. If two angles of one triangle are equal to two angles of another triangle, and that's what we have here, isn't it? Then guess what's true about the third angles? They're going to be equal to each other as well. That's right. So I can put 3 arcs here, couldn't I? And I'm going to come over here and put 3 arcs. All right? Oh, that's kind of weird. But anyway, those are equal to each other. So now, if I called this triangle, what? Benjamin Franklin Holly, then we would call this. Oh, stop it. We're just playing. You're taking this way too serious. Okay. Come on, play along. Be a sport. Okay, so here we go. If I call this BFH, look, what did I do? I went from one arc. I'm saying if they were congruent. This is not enough information to tell that they're congruent, by the way. Did you know that? Because, watch this. Sides could be, watch, if I did this, those angles are still equal. Okay? Well, that's supposed to be there. You get the idea. I'll tell you what. Let's do this. Watch this. Watch. If I did this. Ooh, look at that. Okay? Now watch. That angle right there is still going to equal, okay, this angle over here. It's still the same degrees, but what did I do to the sides? I made them smaller, didn't I? Okay? Let's make them back again. So they're not necessarily, just because the angles are equal doesn't mean they're congruent, but I'm just telling you right now they're congruent. Is that all right? So, is that all right? Rachel, you okay with that? Okay, good. I'm just making sure it was okay. So let's do this. If this is BFH, what are we doing? We're going from one angle, one arc, to 2 arcs, to what? To 3 arcs. So how am I going to name this triangle over here? I have to name it what? CWR. It has to be in that order. Why? Because if this was the only thing that I was looking at, I need to know which angles are equal to each other, which sides are equal to each other. Does it make sense? So look, just by looking at this, without even looking at those triangles at all, I can tell you that B and C are equal to each other, that F and W are equal to each other, and that H and R are equal to each other. All right, let's stop.